Hello guys, welcome to my video. I'm your Chetana studying in Sri Venkateswara College of Engineering, pursuing computer science and artificial intelligence engineering. Currently I'm in second year third sem. In this video, I'll discuss about the concept of ANOVA. Before going to that, what is ANOVA? ANOVA is a statistical technique used to predict the hypothesis or the differences between the groups or data. The full form of ANOVA is analysis of variance, and it is also used to compare the means of three or more groups. And it follows the null hypothesis if the hypothesis is accepted and rejected depends on the null hypothesis. Let's move on to the types of ANOVA, that is one-way ANOVA, two-way ANOVA and repeated measures ANOVA. What is one-way ANOVA? It compares means of three or more independent groups. Two-way ANOVA examines the effect of two independent variables on a dependent variable. Repeated measures ANOVA compares means of the same group under different conditions. Assumptions of ANOVA: independence, normality and homogeneity of variance. Observations within a group independent of each other are called independence. Assumptions: data within groups should be normally distributed. They are called the property of normality. Homogeneity of variance: variance among the groups should be equal. Calculating ANOVA. ANOVA calculates F static by comparing the variance between groups to variance within groups. F static allows an F distribution with degrees of freedom for between and within groups. ANOVA output includes p-value to determine statistical significance. So let's see how to solve a ANOVA problem. So this is a F distribution table for the ANOVA, and here comes the steps. The first one, data representation for one-way ANOVA. Here you can see the entries x11, x12 are the elements of the treatment 1 and x21, x22 are the elements of treatment 2, and it follows until the k, where the 1, the row and column number or the sample values. K is the number of treatments compared. The sample total of ith treatment. Xi is the sample total of ith treatment. Ni is the number of observations in the ith treatment. And the formula is given by the number of elements is the sum of numbers of all the elements. The total variation in the observation Xij can be split into the following components: variation between levels of variation due to different bases of classification, common treatments, the variation within the treatments, that is inherent variation among the observation within the levels. Let's see the steps. Test procedure. Let the observations xij, j equals 1, 2, 3 until mj for treatment I be assumed to be from mu of I to rho square population, that is I equals 1, 2, 3 until k, where rho square is unknown. Step 1, framing hypothesis, that is null hypothesis. We need to give a particular condition. Whether it satisfies or not, we need to check. Or else If the null hypothesis is not satisfied, the situation is called as alternative hypothesis. So this is the first step of framing hypothesis. The second step is data. Data is presented in a tabular form as described in the previous section. Step 3. Level of significance. To find the level of significance. Step 4. Test statistic. For this, we have the formulas F equals MST by MSC. So what is MST? To calculate MST, first we need to find CF, that is correction factor. The correction factor of an ANOVA table is the sum total of the elements of all the elements in the row, in each row, whole square by number of elements, and total sum of squares is the square of elements of each row of the total minus correction factor, sum of squares between treatments, that is SST. It is the squares of each element, sum of squares of each element minus CF. Sum of squares due to error, that is SSC, equals TSS, that is total sum of squares minus sum of squares between the treatments. Next we need to find the degrees of freedom. For finding that total sum of squares degree of freedom, that is n minus 1, that is total number of elements minus 1. For treatment, k minus 1, that is total number of rows minus 1, and error of sum squares, that is n minus k. Mean sum of squares due to treatment equals MST, that is SST by k minus 1, and mean sum of squares due to error, that is MSC, equals SSC minus SSC by n minus k. So using this, we will find out the MST and MSC value. After finding the MST and MSC values, we need to find the F ratio, that is MST by MSC. We will get a particular value. After getting that, we need to check for the null hypothesis of that data. If it satisfies, then it is accepted. If it is greater than the null hypothesis, then it is rejected. Same step, you can see critical value, that is finding the value using degree of freedom, and decision, that is we need to decide whether it is less than or greater than the null hypothesis, or whether it is rejected or accepted. So these are the steps followed while solving the problem of ANOVA. Let's move on to the advantages of ANOVA. ANOVA can handle multiple groups simultaneously, reducing type 1 and type 2 error. It produces statistical significance for differences between the groups. ANOVA allows for testing interactions between variables in more complex designs. Moving on to the conclusion, ANOVA is a powerful statistical tool for comparing means of multiple groups. Understanding the assumptions and types of ANOVA is crucial. Accurate analysis. Practice with different examples to gain proficiency in applying ANOVA in research and data analysis. I think this video will help you guys, and finally, thank you for watching.